This is section 4.6, Maps and Scale Drawings. Our objective today is to use proportions to solve problems involving scale. Let's start with vocabulary. A scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. That means sides will be proportional. Scale is the ratio that compares a length in a drawing or model to the corresponding length in the actual object. This is very important that it is model for drawing over actual. So nobody ever need to use scale drawings. Sometimes we have to make blueprints for buildings, or if we draw a picture of a building. We might also use scale to make like a model of a cell. We can't draw a cell to its actual size, it's too small. We have to enlarge it so we can put it on paper. Let's do our example. The length of the side of a house is 3 centimeters on a scale drawing. We want to find the actual length of the house. Now the important thing here is that 1 centimeter equals 2.5 meters. So we're going to set up a proportion. Let's start with that proportion that it gave us. 1 centimeter is equal to, or over, 2.5 meters. That equals, well, 3 centimeters on the drawing. Centimeters should line up with centimeters. That would equal x meters. Now the labels no longer matter. They're just important to help us line things up. We do our cross multiplication. 3 times 2.5, which is 7.5, and 1 times x, which is just x. So x equals 7.5 meters. There's our answer. If the chimney of the house is 4 centimeters tall in the drawing, how tall is the chimney of the actual house? Try this one on your own. Well, just like the other one, we want to start with 1 centimeter over 2.5 meters equals 4 centimeters now over x meters. We cross multiply, and x equals 10 meters. Now we're going to look at this boxcar. The actual length of the boxcar is 609 inches. So we want to find the scale of this model. So remember, scale is always model. So the model is 7 inches long, over actual, which is 609 inches. Now, anytime you're looking at scale, you want to try to get the top number here to be a 1. So if we divide them both by 7, we get 1 inch over 87 inches. Now we can leave that as a fraction, or we can write it as 1 inch equals 87 inches, or 1 inch to 87 inches, 1 inch to 87 inches. So any of the ways we write a ratio are acceptable. And then we can also do this one with an equal sign when we're writing a scale. So the length of a room in an architectural drawing is 10 inches. Its actual length is 160 inches. What is the scale? Try this one on your own. All right, scale is drawing, so 10 inches, over actual, which is 160 inches. Divide them both by 10, we get 1 inch is equal to 16 inches. There's our scale. You want to make a scale model of a sailboat that is 51 feet long and 48 feet tall. That's the actual boat. You plan to make the model 17 inches long. Find the height of the model. Try this on your own. All right, to do this one, we set up a proportion. Let's set up 51 feet over, well, long, so 51 goes with 17. And then 48 feet over, well, we don't know how tall it is. So let's cross multiply. 51x equals 17 times 48, which is 816. Divide by 51. And x equals 16. Our label, 16 inches long, so 16 inches tall. Here's your assignment.